Chess, a game of war waged on a checkered field. Each piece, from the humble pawn to the mighty queen, has its own unique movement, creating a dance of strategy and foresight. Physics, the study of the universe and its intricate workings. From the smallest particles to the vast expanse of galaxies, it seeks to understand the fundamental principles that govern everything. Seemingly disparate domains, wouldn't you say? One is a game, the other a science. Yet, they share more than meets the eye. Yet, beneath the surface, a shared thread of elegant simplicity emerges. Both are governed by a set of clear, concise rules that, when combined, create a tapestry of infinite possibilities. Chess, with its handful of piece movements, can be grasped by a child. The basic rules are easy to learn, but mastering the game takes a lifetime. Similarly, physics rests upon a foundation of fundamental laws: gravity, electromagnetism, and the like. These laws are the building blocks of our understanding of the universe. These laws, like the rules of chess, are clear, concise, and surprisingly few. This simplicity is deceptive. It belies the depth and complexity that can arise from their interactions. It masks the incredible complexity that arises from the interplay of these basic rules. In chess, a few simple moves can lead to an almost infinite number of game scenarios. Just as a handful of chess pieces can create an astronomical number of possible games, so too can the universe's fundamental laws give rise to stars, galaxies, and even life itself. The possibilities are boundless. It's a beautiful paradox, simplicity at the core, infinite complexity as a result. This is the elegant simplicity of rules, where the basic and the complex coexist in perfect harmony. The path to mastery, however, is paved with more than just understanding these basic rules. You can learn the moves of chess in an afternoon, just as you can memorize equations from a physics textbook. But true mastery, the ability to not just play but to excel, demands something far greater: time, dedication, and a deep, intuitive understanding of the underlying principles. This is where the analogy between chess and physics, or indeed any scientific or mathematical field, truly resonates. Grandmasters spend years studying the game, analyzing countless matches and playing against formidable opponents. They develop an intuition, an almost sixth sense for the flow of the game, anticipating their opponent's moves and planning their own with stunning accuracy. Unfortunately, our traditional education system often stumbles at this crucial juncture. We are taught to memorize formulas, to solve for X, to regurgitate facts on standardized tests. But rarely are we encouraged to truly grapple with the underlying principles, to develop that intuitive understanding that is the hallmark of true mastery. This approach is akin to teaching a budding chess player a series of opening moves, but never explaining the strategic thinking behind them. Sure, they might win a few games by rote memorization, but they will never develop the deep understanding needed to consistently outmaneuver their opponents. They'll be stuck playing checkers in a game of chess. Let's consider a concrete example from the world of chess. Chess, a game of strategy and intellect, often mirrors the complexities of life itself. A novice player might be told, "Never give up your queen unless absolutely necessary." This piece of advice is often one of the first lessons taught to beginners. This advice, while sound, isn't a rule, it's a strategy. It's a guideline meant to help new players understand the importance of the queen. It stems from the underlying principle that the queen is the most powerful piece on the board, capable of controlling vast swaths of territory. The queen's versatility and range make her invaluable. Understanding this principle is far more valuable than simply memorizing the strategy. It encourages players to think critically about their moves. It allows the player to adapt their approach based on the specific circumstances of the game. Flexibility and adaptability are key components of a successful strategy. There might be situations where sacrificing the queen is a brilliant tactical maneuver, leading to a swift checkmate. Such moves can turn the tide of the game in an instant. A player who understands the underlying principle can make that judgment call. They can see beyond the immediate loss to the potential for a greater gain. A player who merely memorizes strategies will be left floundering. They may struggle to adapt when the game takes an unexpected turn, highlighting the importance of deep understanding over rote learning. Section 5. Conventions and confusion. This confusion between rules, strategies, and conventions extends far beyond the chessboard. I recall a time when my son Eugene was grappling with this very issue in his engineering studies. He'd encountered a problem where the correct solution, according to his professor, differed from the one dictated by the fundamental laws of physics. When Eugene questioned this discrepancy, his professor, a seasoned engineer, explained that while the laws of physics were indeed universal, real-world engineering often involved adhering to certain conventions and standards. These conventions, while not strictly dictated by physics, ensured consistency, safety, and ease of communication within the field. Section 6. Beyond Conventions, Universal Truths. Eugene's experience highlights a crucial point. While conventions and standards have their place, they should never overshadow the fundamental principles they are built upon. It's one thing to follow a convention because you understand the reasoning behind it. It's quite another to blindly adhere to it without grasping the underlying principles. This distinction is crucial, not just in engineering, but in any field. Whether you're designing a bridge, writing a piece of software, or formulating economic policy, a deep understanding of the underlying principles will allow you to navigate the complexities of the real world with far greater confidence and creativity. Section 7. YouTube, a classroom of simplicity. Ironically, it was through a platform often associated with entertainment rather than education that Eugene truly grasped the power of simple explanations. He started a YouTube channel where he broke down complex scientific concepts into easily digestible videos. To his surprise, his channel exploded in popularity. Why? Because he wasn't just regurgitating information, he was illuminating the underlying principles, making the complex comprehensible. He wasn't just teaching science, he was sparking curiosity, igniting a passion for understanding the world around us. Section 8. Addition's True Lesson. This approach, focusing on the why rather than the what, harkens back to the difference between memorization and true understanding. Imagine teaching a child addition by simply having them memorize sums. 2 plus 2 equals 4, 3 plus 3 equals 6, and so on. They might be able to spit out the answers, but they haven't truly grasped the concept of addition. Now, imagine teaching them addition using physical objects, allowing them to combine groups and see the results firsthand. They are no longer memorizing, they are internalizing the underlying principle of combining quantities. This deeper understanding allows them to tackle any addition problem, no matter how complex, because they grasp the fundamental concept at play. Section 9. Unveiling the why. The same principle applies to physics, to mathematics, to any field of study. It's not enough to simply memorize equations or procedures. We must strive to understand the why behind the what. Why does this equation work? What principles govern this phenomenon? How can I apply this knowledge to solve new and unexpected problems? This quest for understanding, for unraveling the mysteries of the universe, is what lies at the heart of true intellectual curiosity. It's what separates the passive consumer of information from the active learner, the one who not only understands the rules, but can also bend them, shape them, and use them to create something entirely new. Section 10. The Power of Simple Examples. Often, the most profound insights can be gleaned from the simplest of examples. A falling apple can illuminate the concept of gravity just as effectively as a complex equation describing planetary motion. A simple game of chess can reveal the power of strategic thinking as clearly as a military campaign. This is not to say that complex examples are without merit. They challenge us, force us to think critically, and push the boundaries of our understanding. But it is in the elegant simplicity of foundational examples that we often find the clearest distillation of fundamental principles. Section 11. Your mind, your arsenal. In the end, the true value of understanding the rules and principles that govern our world lies not in the ability to recite them from memory, but in the power it grants us to think critically, solve problems creatively, and innovate beyond the conventional boundaries. This knowledge empowers us to shape the world around us, to mold it according to our vision and aspirations. So the next time you encounter a complex problem, don't shy away. Whether it be in the classroom, in the workplace, or in life itself, face it head-on with confidence. Remember the simple elegance of a chessboard, where every move is a step towards a larger strategy. Remember that beneath the surface, complexity lies a foundation of fundamental principles waiting to be understood, harnessed, and ultimately mastered. Your mind, armed with this understanding, becomes an arsenal of creativity, innovation, and resilience. Capable of tackling any challenge that comes your way, your mind is your greatest tool. Use it wisely, and the world will be yours to shape.